Hello everyone, this is Celine from the Experience Research Lab. Today I'll show you how to run Ordinal Logistic Regression in RStudio. Ordinal Logistic Regression is also known simply as Ordinal Regression. It is closely related to multinomial logistic regression because both can take nominal, ordinal, and scale-independent variables to predict the dependent variable. Between the two, the difference lies in the type of dependent variable, which is nominal versus ordinal. It means that the values in ordinal regressions are ranked from the lowest to the highest. Regarding the values, ordinal regression is also related to binary logistic regression because the dependent variable in both can have two values. Again, the difference lies in the type of dependent variable, which is also nominal versus ordinal. In this video, I will use an SPSS file, and to get the file, I have three options. The first option is by clicking File here, Import Dataset from SPSS. On this dialog box, I need to browse the location of the dataset, and to do that, I'll just click Browse here and go to the folder where the dataset is located, which is in this PC, Local Disk C, Program Files, IBM SPSS Statistics, Samples, English, and the file name is German credit. I can type it here and select it. As shown here, the file name is German credit and it is saved in SAV format. This is the preview of the dataset. And to import the dataset into RStudio, I just need to click Import, but for now I'll click Cancel. The second option is by writing the R script here. And to get the dataset this way, I need at least 3 libraries. So required libraries are library heaven. This is what I need to import the dataset from SPSS. Next one is library mass. By the way, MASS stands for Modern Applied Statistics in S. This is what I need to analyze data later. And the third one is library ggplot2. This is what I need to visualize the data if necessary. So I just highlight these 3 libraries and click Run. Now I've got these 3 libraries in RStudio. It means that I'm ready to import the dataset from SPSS. So get dataset from SPSS and save as credit. So the dataset name will be credit and it is imported from SPSS. Therefore, I will tell RStudio to read the dataset, which is in SAV format, and get the dataset from, I just quickly go to the folder and copy the path by pressing Shift, right click, and then copy as path. Go back to RStudio, paste it here, but I need to change this and this, all of this with this. Great, and this is the last one. Now I click Run. As shown here, I now have one dataset, credit. It has 1000 observations and 20 variables. By the way, the third option to import dataset from SPSS is by clicking Import Dataset in the environment here and clicking from SPSS. The remaining procedure will be exactly the same as with the first option. So I'll click Cancel because I've already imported the dataset with the second option, which is by writing the R script here. To see the dataset, I just type credit and run again. Excuse me. Great. So this is the dataset I've got in the RStudio with several first variables, which are duration, CAMT, instrait, and so on. It's not really clear what these all mean. So to get a better picture of the dataset, I just type structure dataset credit, and run again. So looking at this, I can say that duration is numeric and it refers to duration in months. CAMT is numeric as well and it refers to credit amount. Interest rate is numeric and it refers to installment rate. Resident length is numeric and it refers to residence length. Age is numeric as well, it is age in years. Num_cred is numeric, it is for the number of existing credits. Num_liab is numeric and it is for the number of who will be liable. CHKS is nominal. It is for checking status. So it has 4 values, 1, 2, 3, and 4. CHIST is for account status. It has 5 values, 1, 2, 3, 4, 5, where 1 is for no debt history, 2 for no current debt, 3 for payments current, 4 for payments delayed, and 5 for critical. If you think this is a little bit too much, you can jump to the column or variables you're interested in. For example, here I need to have a look at the structure of the dependent variable. And in this analysis, the dependent variable will be CHIST, which is the account status. So to see the structure of the account status, I just type str credit because this is where this dataset name, and CHIST, this is the variable name for account status. And then click run. So here I can see the structure of the selected variable only, which is the account status. It is, as previously mentioned, nominal with 5 values, 1 for no debt history, 2 for no current debt, 3 for payments current, 4 for payments delayed, and 5 for critical. Since the analysis I will run today is ordinal logistic regression, I need to rank these 5 values from the lowest to the highest. So I will transform the dependent variable. Where the dependent variable is the account status. And I will save it as ordered. Right. Now I'll run it. Now to see the structure of the new dataset, I can simply go back here and then click run. But for this video, I will type it again. So str credit gist. And then click run. So as shown here, the dependent variable account status or gist is now an order factor with 5 levels. 1 is lower than 2, 2 is lower than 3, 3 is lower than 4, and 4 is lower than 5. So looking at this, I can say that no debt history 1 has lower risk than no current debt 2, while payments current 3 has lower risk than payments delayed 4. So to see the distribution of the account status, I can type summary and then credit gist and then click run. So out of 1000 observations, 4 falls to the first category, no debt history, 49 into the second category, no current debt, 530 into the third category, payment current, 88 into the fourth category, payment delayed, and the remaining 293 into the fifth category, critical. Now I can use the library ggplot to visualize the data distribution. of account status. So visualize data distribution of account status by creating bar plot. Where the bar plot will refer to the table of account status in the credit dataset. Click Run again. Shown here, data is not normally distributed because more than half of the data or observations is concentrated in the third and fifth categories. So looking at these distributions, I should expect that the model I will build soon wouldn't be able to accurately predict all these 5 categories. By the way, in this video, I want to build a model that can predict the account status using independent variables that have significant relationship with the dependent variable, which is the account status. There are several variables I'm interested in. They are age, duration of the loan, number of credits at the bank, other installment debts, and housing type. To see the relationship between the account status and these 5 variables, I need to check the structure of each variables. And to do that, I can just simply copy the script from here and then paste it here. So check the structure of dependent variable. The first one is age. Second one is duration. Third one is number of credit. Fourth one is other installments. And the last one is housing type. Right, and now highlight all these 5 and then click Run again. If I just scroll up a little bit, I can see that, as previously mentioned, age is numerical, refers to age in years. Duration is also numerical, it refers to duration in months. Numcred is also numerical, refers to the number of existing credits. Other installments is nominal with 3 levels, 1 for bank, 2 for stores, and 3 for none. And housing is also nominal with 3 levels, 1 for rent, 2 for own, and 3 for free. For the last 2 variables, other installments and housing, I need to transform them into vectors. So transform independent variables into vectors. So the first variable is other installment. So credit. Nope. Save as vector. Great. And the second one is credit housing type. Also save as vector. Credit housing. Great. Now I block these 2 and then click Run. To see the new structures of these 2 variables, I can simply copy and paste them here. Highlight and then Run. So here, other installments is now a vector with 3 levels, 1, 2, 3, and housing type is also a vector with 3 levels, 1, 2, and 3. To see the distributions of account status across these two variables, I can create a cross tabs. So create cross tabs, where the first tab will be cross tabulation between account status and other installments. So other installment, both are in credit data set. And the second cross tabs will be for account status and housing type. Great. They're also from credit dataset. Highlight these two and then run. Looking at this, I can say that data is concentrated in the third other installments and second housing type. To build the model, I need to split the dataset into two samples, where the first samples will be for training and the second one will be for testing. I will save the split as IND, sample of 2. Where the sampling is with replacement, so replace equals true, and proportion of samples will be 3:1, where 75% of the dataset will be for training and the remaining 25% will be for testing. Click run. Now I will assign the first sample into training, where training will be the first sample from credit dataset. And testing will be for the second sample of the dataset. As shown here, now I have 3 datasets. Credit with 1000 observations of 20 variables. I've mentioned this one earlier. And the second dataset is testing. This is a new one with 257 observations and 20 variables. And the third dataset is for training with more observations, which is 743 observations and 20 variables. Now let's have a look at the summary of account status in these two subsets of datasets. And to do that, I can type summary training gist and summary testing gist. Right? Log and then run. It is not much different from the main dataset because out of 743 observations in the training dataset, only 28 fall to the first category, 36 to the second category, 400 to the third category, 66 to the fourth category, and 213 to the fifth category. Meanwhile, for the testing dataset, out of 257 observations, only 12 fall to the first category, 13 to the second category, 130 to the third category, 22 to the fourth category, and 80 to the fifth category. To get a better picture of data distributions of the account status in these two datasets, I can create more bar plots by typing bar plot table training gist for training dataset and bar plot table testing for testing dataset. Correct. Okay, So I just go back here and then here. So this is the data distributions of account status in the main dataset, where data is concentrated in the third and fifth categories. And this is the data distribution of account status in the training dataset, where data is again concentrated in the third and fifth categories. And this is the data distribution of account status in the testing dataset. Again and again, data is concentrated in the third and fifth categories. So looking at these bar plots, I can say that data distribution is consistent across datasets. That is to say that I am now ready to build the prediction model using the training dataset. So build prediction model using training dataset, where the model will be using Polar package from the library mesh, where the gist will be the dependent variable and age plus duration plus number of credit plus other installment and plus housing will be the independent variables. All of these are taken for the training dataset, and has will be true. Run the script. Now I've got the model in my RStudio, which is a list of 19. And to see the model summary, I can simply type summary model. Run again. So here in the model summary, I can see the coefficient value of each variable along with the standard error and t-value. Unfortunately, the Polar package doesn't include the p-value calculation for the regression coefficients, but I can calculate it using the C table. So let us first calculate p-value using C table, where the C table will be the coefficients in the model summary. Click run and then C table. So this is the C table, and now with this C table I can calculate the p-value, where p-value will be p-norm, p in normal distribution with the absolute value of C table t-value lower tail false and multiplied by 2. Click run and type p to see the p-values. So these are the p-values for all variables used in the model. And to get these values into the same table, I can bind the two tables. So C table now will be the binding of C table and p-value table, where p-value is p. Run the script. Great. And to see the last updated or the new C table, type C table and then click run. Here I can see that age now has coefficient value, standard error, t-value, and p-value. Basically, all variables used in the model here now have coefficient values, standard errors, t-value, and p-values. And looking at these p-values, I can say that with 95% confidence interval, all these variables have significant relationship with the dependent variable, which is the account status, and therefore I can keep them all in the model. On that note, I am now ready to do the first prediction. So first prediction using the training data, where the first prediction will be saved as pred, where pred will be prediction using the model and training data. Great. So this is the first prediction. It's also saved here in the environment. And to see the prediction, I can simply type pred and then run again. To assess the model performance, I need to look into the confusion matrix, model accuracy, and classification error. So confusion matrix, model accuracy, and classification error. The confusion matrix will be stored as tab, where tab will be the table of prediction and the account status in the training dataset. Click run. Now I print the tab. So this is the confusion matrix. Let me quickly call the summary of account status in the training dataset. Looking at this confusion matrix, I can say that out of 28 observations classified into the first category, none is correctly predicted. Likewise, out of 36 observations classified into the second category, none is correctly predicted either. But here in the third column, out of 400 observations classified into the third category, 372 are correctly predicted. In the fourth column, out of 66 observations classified into the fourth category, none is correctly predicted. And in the fifth column, out of 213 observations classified into the fifth category, 145 are correctly predicted. To get the percentage of the model accuracy, I can divide the values in the confusion matrix. So tab divided by the sum of values in each column. So call sums tab. Great. So this is the percentage of the model accuracy, which is 0% for the first category, 0% for the second category, 93% for the third category, 0% for the fourth category, and 68.08% for the fifth category. So the model accuracy to predict each category is printed in the diagonal line of the confusion matrix, and therefore I can get the overall accuracy of the model prediction by dividing the sum of values in the diagonal line of the confusion matrix and then divide it by the sum of values in the confusion matrix. Click run. So here is the overall accuracy of the model prediction using the training data, which is 69.59%. And to ensure the consistency of the model performance, I need to do second prediction using the testing data. So second prediction using testing data, I can simply copy this and paste it here, but the second prediction will be stored as pred1, where pred1 will be the prediction using the model and testing dataset. print the prediction, the second one. Oh, sorry. Correct. Just like the first prediction, I also need to look at the confusion matrix and modal accuracy by copying this and pasting it here. So this will be tab 1 with the first prediction and testing dataset, and tab 1 here, tab 1 divided by summary of values in column of confusion matrix 1, and tab 1 here as well. Now with the second prediction, the modal accuracy to predict the first category is 0%. Second category is also 0%. Third category is 89.23%. Fourth category is 0%, and the fifth category is 65%. So overall, the modal accuracy in the second prediction is 65.37%. Now I'll call the modal accuracy for the first prediction. Again, this is the overall accuracy of the model for the second prediction, and this is the overall accuracy of the model for the first prediction. And looking at these two figures, which are not much different, I can say that the model performance is consistent across datasets. And therefore, I can now write the equation for the model by calling the C table. So the equation for the model will be 0.014 times age minus 0.012 times duration plus 2.090 times number of credit plus 0.554 times other installment type 2 plus 1.229 times other installment type 3 plus 0.505 times housing type 2 plus 0.084 times housing type 3. Now I can calculate the probability of each observation in the main dataset, which is credit. So calculate probability of observations in main dataset, credit, where the probability will be saved as prop, and prop will be the prediction using the model, and for several observations, so head, credit, and I will print it as percentage of probability, so type will be probability. Great. Now click run. Here I can see that the highest probability for observation number 1 is in the fifth category, and therefore it will be predicted to the fifth category, while the highest probability for the second observation is in the third category, and therefore it will be predicted to the third category. The highest probability for the third observation is in the third category as well, and therefore it will be predicted to the third category. Observation number 4, the highest probability is in the third category, therefore it will be predicted to the third category. Observation number 5, the highest probability is in the fifth category, and therefore it will be predicted to the fifth category. And observation number 6, the highest probability is in the third category, and therefore it will be predicted to the third category. To see if this prediction is accurate or no, I can classify the observation based on the maximum probability. and print it all together. So prop will be the prediction using the model, and for several observations, so head credit, and that's it. Click run. Yep. So as previously mentioned, observation number 1 falls to the 5th category. Observation number 2 falls to the 3rd category, 3rd here. Observation number 3 falls to the 3rd category, 3rd category here. Observation number 4 falls to the 3rd category as well, 3rd category here. Observation number 5 falls to the 5th category, 5th category here, and observation number 6 falls to the 3rd category, and it is 3rd category here. So looking at this output, I can say that the model is actually doing a pretty good job at predicting the 3rd and 5th category. However, it's not working as expected to predict the 1st, 2nd, and 4th categories. And that's how you run Ordinal Logistic Regression in RStudio. For more insights into data, including data entry, data transformation, data analysis, and data visualization in SPSS, Microsoft Excel, or RStudio, please subscribe, listen, and watch our content that is available in text, audio, and video format. Thank you for being with me today. I'll see you next time in the other videos. Cheers!